Have you ever seen a rocket launch and just wondered how it actually gets off the ground? It looks like pure brute force, this massive metal giant defying gravity itself, but the science behind it is both elegant and incredibly powerful. Today, we're diving deep into the heart of a rocket to uncover the secrets of its thunderous ascent. So, let's start at the launch pad. We see this colossal structure, standing tall, pointed at the sky. It's filled with hundreds of thousands of gallons of super-chilled propellants. These aren't just one type of fuel, it's a carefully crafted cocktail. In most modern rockets, we're talking about two main components: a fuel, like kerosene or liquid hydrogen, and an oxidizer, usually liquid oxygen, or LOX for short. Why an oxidizer? Simple. There's no air in space, so the rocket has to bring its own oxygen to burn the fuel. These liquids are kept at incredibly low temperatures, hundreds of degrees below zero, to keep them in a dense liquid state. Now, let's zoom into the engines, the real powerhouses of the launch. Deep inside, you have these incredibly complex pieces of machinery called turbopumps. These are spinning turbines that pump the fuel and oxidizer from their tanks into the combustion chamber at insane pressures and speeds. We're talking about moving the equivalent of several swimming pools of liquid every minute. This is where the magic, or rather, the physics, happens. Inside the combustion chamber, the fuel and oxidizer are mixed together and ignited. The moment they meet, an intense, controlled explosion occurs. This chemical reaction releases a tremendous amount of energy in the form of hot, high-pressure gas. The temperature inside can reach over 3,000 degrees Celsius, hotter than the melting point of steel. So how does this explosion make the rocket go up? It's all about Newton's third law of motion. For every action, there is an equal and opposite reaction. The combustion chamber is designed like a bell, called a nozzle. It directs all that superheated, high-pressure gas downward. As the gas is violently expelled out of the nozzle at supersonic speeds, it creates an incredible amount of force pushing downwards. This force is the action. The reaction is an equal force pushing the rocket upwards. This upward force is what we call thrust. To lift a multi-million-pound rocket off the ground, you need thrust that is greater than the rocket's weight. A lot greater. Let's visualize the countdown. T-10, 9, 8. At this point, complex computer systems are running final checks on thousands of components. 7, 6, 5. The engine ignition sequence begins. You might see sparks from the igniters. 4, 3, 2. The turbopumps spin up to full speed, and the main valves open, flooding the combustion chambers with propellant. 1. Ignition. You see that brilliant flash of light. At first, it's a bright blue flame, a sign of a clean, efficient burn. This is the moment of maximum power and pressure. The engines roar to life, and the ground begins to shake violently. The sound isn't just a loud noise. It's a physical force that you can feel in your chest for miles around. Massive clouds of smoke and steam billow out. That steam is actually from the tons of water being poured onto the launch pad to absorb the intense heat and sound energy, protecting the rocket and the pad itself. For a few seconds, the rocket is held down by giant clamps. This allows the engines to build up to full thrust and for computers to verify that everything is working perfectly. Then, we hear the call, lift off. The clamps release, and the rocket begins its slow, majestic climb. It seems to move in slow motion at first, fighting against its own immense weight and Earth's gravity. But it's accelerating, faster and faster. As it rises, you can see the flames expanding. This is because the atmospheric pressure decreases the higher it goes, allowing the exhaust plume to spread out. The rocket punches through the thick lower atmosphere, leaving a long, bright trail behind it. Inside the control room, engineers are monitoring every single piece of data, making sure the trajectory is perfect. But what about those rockets you see on the side? Those are called solid rocket boosters, or SRBs. Many heavy-lift rockets use them for an extra kick during the first few minutes of flight. Unlike the main liquid fuel engines, these are filled with a solid, pre-mixed propellant, kind of like a giant firework. Once they're lit, they burn until they run out of fuel. You can't turn them off. They provide a massive amount of extra thrust to help get the heavy rocket moving. After about 2 minutes, the boosters have used up all their propellant. They've done their job. At this point, the rocket is tens of miles high and moving at several times the speed of sound. Small explosive bolts fire, and the massive, empty boosters detach and fall away, eventually parachuting into the ocean for recovery and reuse. You see the rocket suddenly get lighter and accelerate even faster. This process is called staging. The main engine, or the first stage, continues to fire, pushing the rocket higher and faster, arcing it out over the ocean. Eventually, it too runs out of fuel. It separates and falls back to Earth, sometimes landing itself on a drone ship for reuse, which is an incredible feat of engineering on its own. Now, the second stage engine ignites. This is a smaller, more efficient engine designed to operate in the vacuum of space. It carries the payload, whether it's a satellite, a capsule with astronauts, or a probe to another planet, the rest of the way into orbit. It's a symphony of fire, physics, and incredible precision engineering. From the supercooled liquids to the controlled explosions and perfectly timed staging, every single part has to work flawlessly. The next time you watch a launch, you'll know it's not just a big firecracker. It's the culmination of decades of science and human ingenuity, all working together to push the boundaries of exploration and reach for the stars. The sheer power is mind-blowing, and it's a testament to what we can achieve. Thanks for joining us on this deep dive into rocket science. If you found this as fascinating as we do, make sure to hit that like button and subscribe to HowScene for more mind-blowing science explained. We'll see you in the next one.